Hello, wonderful students. I am making some help videos for 508 and 509 on a Friday. So if you're not watching this on a Friday and you're wondering why in the world is she dressed so casually, it's because it's a Futures Friday where we encourage you to think about your future. And we're pushing this idea of 3 E's, and I like it. Enrolled, meaning enrolled in school, enlisted, or employed. So those are great goals out of high school. I highly recommend one of those three. I really do. Whatever it is. Mine out of high school was working at a store in our local mall called Buckle. It was a cool experience, and I'm glad I did it. And then, then I was also going to school at our local community college. So this is a shirt from a winery. You do need to go to college if you want to kind of enter that business. I'm from Northern California, and the wine industry is very, very big up there. So our colleges in Northern California have programs just for the wine industry. Everything from wine accounting, business management, wine like a business degree, but an emphasis on wine, and growing, managing your staff. So it's very interesting. So that's both enrolled and employed. This hat is given to me by a family friend and by his wife, and he was in the military and he was a medic in the military and designed his own pouch for what he needed for his medical purposes. But it was so great, he decided to patent it, produce it, and now he has his own company and is selling his product back to the military to be part of the gear for medics. So that went from enlisted to self-employed. Lots of options out there. Keep going. As always, my little soapbox in the beginning of our help videos. Thanks for watching. You can always just be like, I don't need to listen to this, and skip to what you want. Okay, 508. Please remember, we have these wonderful problems, explanations, video, and practice opportunities right here in your online course. Okay? So maybe come to class, watch these videos, practice in here, see what helps click in your brain. I know you can do it. I never said it would be easy, right? It gets easy, but after you put in the hard work. Watching these videos, trying retakes are the first steps, but ultimately it's up to you to get in there, try it on paper, try it on a digital notebook, and do the thinking. This is my honors course, and there we are. That's okay. So I need a couple more of my students to take it in my honors class, and this is kind of where I do expect them to be. So for those of you who aren't in my honors course, that's okay, right? That's absolutely okay. These students should be pushing themselves to their absolute limit of understanding of mathematics, okay? And they are. Typically they are, and I appreciate them. And you, every one of them. But let's take a look at this quiz. 508. Let's see. Let me zoom in. Why did I sigh? Operations with rational expressions have a lot of skills all rolled into them. We look for multiples, factors. We use fractions. We have to use factoring patterns and polynomials. So lots and lots of skills in here. So let's talk about it. When I see this subtraction symbol of fractions, adding and subtracting fractions requires a common denominator. That makes sense, right? I cannot do 1/4 minus 1/2 and then just get 0 halves. It's true, I would have 0 halves. I'd actually have negative, but let's flip it. Let's do 1/2 minus, let's do minus, let's do 3/4 minus 1/4 would give me 2 halves. That doesn't make any sense. That's 1 whole, and we know that's not true. So do you see how we can't just add and subtract straight across? We can with multiplication. Whenever you think of adding and subtracting fractions, a common denominator is required. So we're speaking in terms of the same amount, right? If I wanted to subtract 1/2 from 3/4, I need to at least understand how much I'm subtracting. This is a visual. When we use polynomials, it's a little bit harder because of that variable, but we know if their denominators are the same, then it will be true. That's kind of the why behind the what. At this point, we take into the skill of looking for an LCD, least common denominator, which is just fancy for the least common multiple of the denominators. So in this case, we have x minus 2, comma, x plus 5. If you had more, you could list them, right? In this case, those are the only two we have. The least common multiple of these two expressions, right? These are binomials, is actually just going to be multiplying themselves. So that's why our common denominator, if you see, for all of your answer solutions, which is a good test-taking strategy for a hint, is simply going to be the denominators multiplied together. They didn't multiply them out because that's not what we really need to know. Sometimes we don't have to FOIL because that's not what we're really worried about. We're worried about the numerators now. Once we find a common denominator, look for the top. So this idea of cross multiplying works in this case too. You just have to be careful because you are subtracting. What is happening is you are simply multiplying this side by a clever name for 1, multiplying this one by x plus 5 over x plus 5. The denominator becomes our common denominator, and this term becomes 2x times x plus 5 in the numerator. Okay. Then, same idea over here, you're multiplying the top and bottom. We have to multiply the top and bottom. What you do to the top, you do to the bottom. Great strategy to remember. The why behind that is the identity property. X minus 2 over x minus 2. Same thing divided by the exact same thing is 1. And then the identity property says 1 times whatever you're multiplying it by stays the same. You never lose your identity. Okay? So we have this, though. We need the subtraction of x plus 3. Ooh, keep an eye on those subtraction symbols. The signs are going to get you. They are going to get you. Trust me, they get me. They get me in class. You guys help me. Sometimes I write the wrong one for absolutely no reason, and I don't know why. I do know why. It's because I'm trying to write, talk, and think at the same time, and it's quite difficult for me anyway to do successfully. But you guys are wonderful. You check me out, you follow along, and you help me when I make those mistakes. Teamwork. So, okay, but that doesn't help us. None of the numerators match. So how did they get this one? You might have a different one. The steps are going to be similar. You're going to have a very similar equation. It's not going to expression. It's not going to be the same as this, but very similar. The strategy is going to be the same. Here we go. I'm going to multiply this out now. This is going to become, using the distributive property, 2x squared plus 10x. I'm going to FOIL this, or you could use the box method, but really you're just making sure each term is multiplied by each term. Plus 3x minus 2x minus 6. Checking my signs. That looks good. Okay. Now, this subtraction, I'm going to use parentheses after we combine like terms, has to be distributed through each one. This becomes 3x minus 2x, which is just x, minus 6. What does that mean, distributed to each one? Well, this is saying subtract that whole thing inside of there. So now I have to take away x squared. I have to take away x, and I have to take away negative 6, which makes it a positive. A negative times a negative is a positive, or if you think of the opposite symbol as the opposite of the opposite, is itself. If the opposite of negative 6 is positive 6. Anyway, remember when you see a double negative, it makes it a positive. Just like if I say I won't never steal. I'm sorry. If I will never steal, if I will not never steal, I'm saying I'm going to steal at some point. It's a double negative. So anyway. Okay, now that I've done that, I can combine like terms. I now have minus x squared minus 2x squared. So I get x squared minus x from 10x. So plus 10 minus 1 is positive 9x. And you can think about that in the sense of if I have 10 x's and I'm taking away 1, that invisible 1, then I'm left with 9, right? And plus 6. That's it. All over our common denominator, which was just multiplying them together. Boom. I'll do this again with addition. We don't have to distribute, and I'll just kind of go through the exact processes and less of the why. But depending on what expression you have, and notice I changed from expression when I accidentally said equation. Why? X squared plus 9x plus 6. Whew, we did it. Okay, let's get out of this. Let me clear out of this. I'll leave my face over there. That's fine. Oh, there's variation 2, so you might have a different one. Let me close this. And question 2. Awesome. Okay, again, these are going to be similar. So you have to pay attention to your problem, not the answer. The steps, the solution, the strategy, all of that is very important, not just the answer. First thing, this is saying division. We talked about this in class. Change it to multiplication, flip. The big idea is multiplying by the reciprocal is the same as dividing by the original number. That's always true. 1 divided by 2 is the same as 1 times 1/2. Isn't that cool? I think it's cool. Anyway. Alrighty. I would like to zoom out, scroll over, use a darker color, and maybe make this a little tinier. Okay. Let's zoom back in now. I'm going to just rewrite it so we at least have that going for us. C squared minus 4c plus 4 all over 12c cubed plus 30c squared times, so we keep the dividend the same, change it to multiplication, flip. Oof, I almost didn't. I almost just rewrote it, which is common, totally common. That's all right. We just check our work, check our steps, check our options for solutions. If we don't get anything on there, like, oh, what did we do wrong? Perfect. That's what we want to know. What did we do wrong? And that's okay. But being wrong in math class is probably the best place to be wrong, because if you wrote it on paper or somehow wrote it down, you could go back and check your work and be like, aha. And we can go back in time in math because we invented erasers, mathematicians. That's not true. I have no idea who invented erasers. Okay, we perfected the use of them. This is still a hot mess, Mrs. Reynolds. I don't know what to do. Cool, I copied dot, I flipped it. That's great. That's great practice. Writing that on paper is great practice. Good for your brain. Developing those pathways. Well, we need to factor. Right? We need to factor. And straight enlisted for future Fridays. This is my husband's cup. His old team gave it to him. He was on this team, and they gave it to him as a going away present because he loves coffee. And anyway, factor. We need to factor. C squared minus 4c plus 4. See if that factors. C squared minus 4. Factoring patterns. And we've got to start to recognize them, right? At least right now. At least to get through algebra. At least to take your spring tests. And then if you're continuing in college, just kind of keep it in their mind. Patterns are great. And then take a look at these. If I ever see numbers and variables, I always try to factor out numbers and variables. So let's see what I see over here. For this top one, remember we're going to look at this 4. We list its factors, okay? 1 times 4, 2 times 2. Those are my only options. Once we list the factors, we need to think what combination, and when I say combine, I mean we could subtract, we could add, we could subtract one, add the other, subtract the others, add the other, right? That's what I mean. To get to -4. Is there any way to get to -4? And I see it, -2 minus 2 combines to make -4. But when you do -2 times -2, we get back to +4, which is what we want, especially since there's no coefficient in our squared term. That's nice for us. We know it's going to factor to c minus 2 times c minus 2. Just for properties of equivalency, note you could have written it c minus 2 squared. This, my friend, is a perfect square. That's what we call it. And when you FOIL it out, it looks like that. Okay, but I'm going to leave it like that for simplifying rational expressions purposes. Now looking at this 12c cubed plus this 30c squared, when somebody asks you to factor, those of you who are already like, oh, I see it, great. For those of you who don't, they're looking for something that you can divide out of all of those terms. In this case, we have 2, that you can do that to both of them nicely, meaning no decimals, no leftover fractions, no weirdness. I tried 12. That didn't work because 30 isn't divisible by 12. I start to think of the numbers that when they combine or divide, 2 times 6 is 12, 3 times 4 is 12. Oh, 3 and 10 make 30. Maybe try 3. Let's try some of the other numbers. 6 into 36 times 5. But whatever steps you take on your paper, in your mind, to figure out what factors they have, try to always look for the largest to save you time. But if you do it, like say you saw a 2, take out a 2. We'd be left with 6c cubed plus 15c cubed. Say you saw there was a 3, because 3 times 4 is 12 and 3 times 5 is 15. Boop, you take out the 3, don't forget to multiply by the 2, you're left with what you would do if you found the GCF. All right, I don't know if that made sense, but let's do it. I'm going to factor out a 6 and a c squared, because that's as many variables as I can take out. So I'm going to take out a 6c squared times, what will that be? What's left? Okay. When I think about what's left, when I factor, you can either divide. Perfect. I think in multiplication, but it's up to you. What makes more sense to you? I divided this by 6c squared. That leaves me 2c. I think of multiplication, the distributive property. I love the distributive property. I always think of it. I have this, and outside that we're multiplying by the parentheses, and a plus or a minus inside. I'm going to distribute. 6 times 2 is 12. C squared times c gets me back to c cubed. Okay, then we'll be left with 5. Just 2c plus 5. Because when you do 6 times 5, you get 30. Check. And then times the c squared, you get the c squared. Check. Okay. Over here, same idea. 6c4 plus 15c3. I see 3 c's I can take out. I'm going to take all of them. Can I take out a 6? No. A 3. I can take out a 3. So in my mind, I just started to look at common factors, meaning the littler numbers that when multiplied together equal the bigger number. In this case, 2 times 3 and 3 times 5, they have a common 3. So I'm left with a 2c plus 5. Look at that. We want that. Remember, this is math class. We want it to kind of be nice and neat. Okay, c squared minus 4. We have a pattern for this. We call it the difference of squares. Are you guys sick of hearing me say it? If you're watching these videos and practicing, you will see that I mention this often when it comes to factoring patterns. Try it. Just always try it. This is a difference of squares. This means it's going to become c minus 2 or plus 2. I know if the quizzes ever mark you off for switching those, they're wrong because multiplication is commutative, which means order doesn't matter. Said this before. 2 times 5 is the same as 5 times 2. 10. Now we get to see how this is the final answer. Let's see. Here we go. Ready? It's the fun part. It's the cancel culture part. As our classmate cleverly identified it. We have a C minus 2 in the numerator. We have a C minus 2 in the denominator. When we multiply straight across, this is why we can do this, they'll end up right over each other and they'll equal 1. So we can get rid of them right now. We have a C plus 5 in the numerator and a C plus 5 in the denominator. Again, when we multiply fractions, we just multiply straight across. So they'll end up dividing each other out and becoming 1. At this point, if you don't see how else you can simplify, you're like, this still doesn't make sense. How'd they get C over 2? Just rewrite it. That's a very valid step. Take what you have left. Okay, I have C minus 2 times 3C cubed. So far, so good. I have 6C squared. I'm going to write it here. I can do that because of commutative property. And then C plus 2. Okay. I see that at least I have that part right. C minus 2 over C plus 2. But how did they get the just a C over 2? Look again on how you can simplify rational expressions. C3 over C2, either using rules of exponents that let you subtract them when they have the same base. That would become, you subtract the exponents if you have the same base and you're dividing. That would become C3 minus 2, which becomes just C. Check. Or you could think of it as writing it like cancel culture, C times C times C all over C times C. And then here's the subtraction property. That becomes 1, that becomes 1, so you're left with just a C. Okay, so this would just become a 1, and this would go away completely. What about this 3/6? Well, just thinking about 3/6 in general, simplifying fractions, please see how that is 1/2. Okay? Otherwise, you can think, well, let's try dividing 3 by 3. 3 is prime, so that's your only option for simplifying. 3 has no other factors, just 1 in itself. And so then we'll try the 6 divided by 3. Aha! 3 divided by 3 becomes 1. 6 divided by 3 becomes 2. And then there's your C, there's your 2. That's how you do question 2. It's a lot of thinking, friends. That's why. And I really appreciate you taking the time to watch these videos. I care. You matter. You have to do the work. I'm willing to do the work too. I'm willing to meet with you, answer your questions, do these videos, whatever it takes. I just can't actually do the physical work for you or the mental. Okay. That was it. Let me zoom out. No, I don't want to pause. I need to go to the next question. Here we go. We're going to do variation 3, and I'm just going to solve it directly. Ready? Okay. Finding the common denominator, x plus 3 and x. Yes, they have an x in common, but there's no way I can multiply something to get that plus 3. It just isn't going to work. So I'm going to multiply them together. So my new common denominator is going to be x times x plus 3. I don't know if they distributed it out and got x squared plus 3x. I don't know. I'm going to leave it like that for now. Now, the next thing is I need this to be x times 3x over x plus 3 times x. Okay, see the x over x? I'm just multiplying the other fraction in my adding expression so that I have a common denominator, a clever name for 1, plus, now this one has to be multiplied to this one. I'll have x minus 2 over x times x plus 3, that's a plus, over x plus 3, right? That's a clever name for 1. Now I have a common denominator, so I can just deal with adding the numerators. So 3x times x becomes 3x squared plus, foiling this out, I don't have to worry about distributing a negative sign. I'm not subtracting that whole expression. I'm just adding it. And because adding is associative and commutative, meaning I can regroup, I can reorder, I don't need to worry about parentheses. So x squared, right? X squared minus 2x plus 3x. So I should just get plus x. Ooh. Yep, okay. Minus 6. That should simplify to 4x squared plus x minus 6 all over that expression. Let's see. 4x squared plus 6 minus 6. Yes, plus x minus 6. Yay! Okay. 4x squared plus x minus 6. 4x squared plus 6 minus 6 all over x times x plus 3. We did it. Whatever yours is, the strategy is the same. You have to pay attention if it's adding or subtracting. If it's subtracting, you have to subtract each term. Change it to a positive. Change it to a negative if it's a positive. Change it to a positive if it's a negative. Basically doing the opposite operation inside the parentheses and then combine like terms. Okay, here we go. See? Question 3 was easier. 4, easier. It's already in multiplication form. Look at this. All I'm going to do is factor. See, we just had to talk about it. Okay, I don't have to flip anything. It's already multiplying. When you multiply fractions, just multiply straight across, which just means you multiply the numerators, you multiply the denominators, and then you simplify. Or you could simplify first, which I recommend doing because this is going to become a binomial times a trinomial, right? And you're going to have all sorts of wild expressions. So let's try to factor first. A minus 2 is as small as it's going to get, okay? If you'd like, I'm going to just leave it. A minus 2. I'm going to put parentheses. I like parentheses. You can use parentheses as much as you want. This one, I'm going to pull out a 6, and I'm going to pull out an A. When I say pull out, I'm thinking division and multiplication. This will then just be A, right? Because when I multiply that back, I'll get back to 6a squared. That's my goal. Now this will become 5. A minus 5, right? Because I'd get 6 times 5, negative 5, which would be negative 30, times the A, which is negative 30a. Excuse me. It is windy over here and dusty. Okay. Now I want to factor this top one. We'll just keep going with the top. Notice how we're all multiplying. This means multiply. So does this parenthesis. It means multiply. So I'm just going to keep multiplying. And multiplying is also associative and commutative. So order doesn't matter, and neither does regrouping, as long as you're grouping the factors. The factors, not inside the parentheses. That is the whole thing. That's the whole factor. A minus 5 is the whole factor. 6a is the whole factor. Okay, I know it's going to factor into something. Aha, factor again. So many words. Like this. I'm going to look at that constant term, 8, and this middle term. 8 is 1 and 7, 2 and 4. Okay, I'm going to need to use 2 and 4 to try to get to 2. Oh, okay. Look, so I'm just kind of running some iterations in my mind. I'm subtracting 2 and adding 4, and that got me to 2, positive 2. I have to look at the sign. And then now if I multiply negative 2 times 4, do I get back to negative 8, which is the sign I need for this one? Yes, I'm done. Minus 2 plus 4. Ooh, that's good news. I already see these two match, so they'll cancel. Let's factor this bottom denominator of our factor. I see, oops, I'm going to take out a 2 and an a squared. 2a squared, because I want to take out as much as I can. Divide out, pull out everything, the greatest common factor, GCF. I'll be left with just a, right? Because when I multiply that back out, I'll get 2a cubed. Minus 5. Is that right? Lovely. Lovely. Check it. See? 2a squared, you'll get your a squared back, and then your 2 times -5, you get your -10. Now's the fun part, positive cancel culture, in the sense that we get to find what's equivalent or equal to 1 and remove it. A minus 2 divided by a minus 2 is 1, so we can cancel it. A minus 5 divided by a minus 5 is 1, so we can cancel it. What's going on here? What happens when we have a larger exponent in the in the denominator than in the numerator? You can still, again, use exponent rules. Rules of exponents say when you have the same base being divided by the same base, you can subtract their exponents. There's that invisible 1. 1 minus 2 will become a to the -1. Still moving with rules of exponents. That's all right, because that's just 1 over a, right, with that invisible 1 right there. Properties of exponents and what a negative exponent means. Otherwise, you can just think of 1a is going to get rid of on the top, and then one of the a's in the denominator. You're left with an a, right? Because a over a equals 1, but you're left with 1a in the denominator still. Same idea here. 6 divided by 2, that 2 just becomes a 1, and the 6 becomes a 3. I don't know. All right, there's 3 that's left in the numerator. And a plus 4, oh boy, all over just this one little a, if we did this correctly. And by we, I mean me, because you're not with me to help me. 3. Uh-oh. Oh, no, that's okay. Look how that's not the same. It's not the same because of the distributive property. We can't just put the 3 times a. We've also got to multiply it by the 4. So if they have 3a plus 12, we're golden. Let's keep going. Oh boy. Okay. 3 parentheses a plus 4 over a. It won't let me scroll though. Or the 12 like I just talked about. We did it. This is equivalent to 3, which is what we found. They just distributed out and got 3 times a plus 12 all over a. These a's do not cancel, right? Because we can't cancel across addition, only when they multiply in their factors. Woohoo! I'm having fun with you guys. I hope you're having fun too. Let me try to adjust this so I don't have to keep doing that. I want this to go up, this to scroll down, close this, and then, no, very fresh. There's a scroll bar within a scroll bar. That's the hard part, see? Okay, 1, sure. We'll just do number 1. We will just do number 1. And here we go. This is a complex fraction, friends. Fractions and fractions and fractions and oh my. This is lots of different ways to think about this, truly. What I would do is simplify the numerator, simplify the denominator, which just means make them common, put them over the same denominator. Okay, so let's just do that. 3 over x, see? Just doing 3 over x plus 1/4. Hey, that's pretty cool. X and 4, they have no common factors, so I know the common denominator is going to be 4 times x. So I'm going to multiply this side by 4 over 4, just like we do with regular numbers, and this side by x over x. Multiply the other one by the other one's denominator, the other one. This becomes 12, and that becomes 12 plus x. Cool. That's just our numerator, though. Now let's take a look at our denominator of our complex fraction. Complex in the sense that it's complicated, not complex in the sense that it has an I. Okay, 1, we're just going to make that x over x. Why not? You can think of it as multiplying by x over x if you'd like, but 1 is a special number, especially in multiplication. Okay, pretty good. So then we'll end up with x plus 3. And then this is our new rational expression that we're asked to simplify. We've got 12 plus x over 4x divided by, that's what the fraction bar means, x plus 3 over x. Well, since this means division, and we've talked about this, I will keep repeating it. I'll never stop repeating. Repetition is the best way to learn, right? That means division. I'm just going to copy dot flip. Why not? Why not, friends? Can you see any reason why not? Okay, keep the dividend the same. The numerator is the number being divided. Oops, no. We would like to change that to multiplication. Multiplying by the reciprocal is the same as dividing. So the reciprocal of this lovely rational expression is just x now becomes your numerator, and x plus 3 becomes your denominator. Okay, at this point we can do our canceling if you'd like. Got to be a little bit careful here. X, and that's it. That should be it, friends. Unless I made a mistake, which is possible. We've seen that. 12 plus x all over 4 times x plus 3. And you could distribute that out. If you did, you'll see a 12 and an x, and you might be tempted to try to rearrange it and cancel, like, there's a 12 and an x, we're left with 1/4. We can't do that because it's not one of the properties of math that keep the equation or the expression true. Okay? We have to always do things that hold those properties of equality. So let's go see what the exam says. We're looking for 12 plus x over 4x plus 3 or over 4x plus 12. This is also a valid solution. If you put this and you got marked wrong, or you put this and you got marked wrong, let me know. You deserve those points back, okay? So this option or this option are going to be a valid solution. Let's go see. We did it. Thank you for watching this. I know it was quite long, but I appreciate your thinking, your patience, and I hope that these are helping. If they're not, be like, Miss Reynolds, don't waste your time. I click through them and no. Or Mrs. Reynolds, yes, thank you. Keep doing these. They are helping me. Either way, let me know. And as always, I'm just an email or a Teams or a phone call or text away.